All right, so we made it to 10.5, day 2. Still looking at our laws of logarithms. What we're going to do with this lesson is just kind of apply everything we've learned in the chapter all in one problem. So, example 1 says to simplify. We have 5 times log base 4 of 2 plus log base 4 of 2. So we're going to use our laws of logarithms to rewrite this in terms of one logarithm. We can see we have a log base 4 of 2 and a log base 4 of 2. So we are going to kind of work backwards from the laws that we had. So we've got this 5 out front. So if you remember, that started from, or that went out front because it was an exponent. So really this is log base 4 of 2 to the 5th power plus log base 4 of 2. All right, now that we have these two log base 4s, and with the addition in front means that our 2 to the 5th and our 2 were multiplied. So log base 4 of 2 to the 5th times 2. So now we'll go ahead and simplify. If you notice, we did get it down to just log base 4. We don't have our two separate logs anymore. So we have log base 4 of 2 to the 5th is 32 times 2. We're just going to go ahead and keep simplifying this. Log base 4 of 32 times 2 is 64. So our goal is to use our laws of logarithms and simplify this down to just one logarithm. Now we go back to the first lesson that we learned and say, all right, we know that that's equal to x. You start with your base, work your way around, write this in exponent form. So 4 to the x power is equal to 64. So 4 raised to what power is 64? Whoops, where'd that go? All right. And that is going to be 3. All right. Next example. First, we've got the number out front, so we know that that was an exponent. So we have log base 5 of 10 squared minus log base 5 of 4. And then we notice that it's subtraction. So when it's subtraction, we're working backwards. This came out of division. So that means that we were dividing the 10 squared and the 4. So that's going to be log base 5 of 10 squared divided by 4. So we got it down to one log, which is good. Now we're going to keep simplifying. 10 squared is 100. And then 100 divided by 4 is 25. So we have log base 5 of 25. Now we're ready to evaluate what this logarithm is. So we set it equal to x, set it up in exponent form. 5 to the x power equals 25. And we know that 5 squared is 25, so x equals 2. So just a couple more examples. We see there's nothing in front of our logarithms, which means there's no exponents, but there is subtraction. So we know that the 44 gets divided by the 11. So log base 8 of 44 over 11. So 44 does divide by 11. It gives us 4. Now we have that simplified, so we go ahead and set it equal to x, rewrite it in exponent form. 8 to the x power is equal to 4. So when we worked on these a couple lessons ago, we knew that we had to make these bases the same. So 8 and 4 I can both write in terms of 2. So 8 is equal to 2 to the 3rd power. I'm just going to bring down that exponent of x. And 4 is equal to 2 squared. So now we have our same bases of 2. If your bases are the same, well actually let's go ahead and simplify this real quick. When you have those two exponents, those will be multiplied. So you have 2 to the 3x is equal to 2 squared. Now that our bases are the same, that means that our exponents will also be the same. So that's the equation we write to solve for x. 3x equals 2. Divide both sides by 3, and x is equal to 2/3. All right, last one up here. We have log base 3 of 2 minus log base 3 of 54. So kind of similar to the last one, I look for those numbers out front of the logs to see if we bring in an exponent, which we do not. And then I'm going to notice the subtraction, which means we will divide So we write log base 3 of 2 divided by 54. Well, you guys know that 2 does not divide by 54, but can we reduce the fraction? And yes, you can divide them both by 2 and get 1 over 27. Okay, now we're going to evaluate this logarithm. Set it equal to x, get it into exponent form. 3 to the x power is equal to 1 over 27. Our goal is to get the same base on both sides. This one has a 3, that one is a 27. So let's go ahead and write the 27 in terms of 3. That is equal to 3 to the third power. And now we're going to go ahead and bring that up to the top. When we do that, we know that we will change the sign of our exponent. So that becomes a negative 3. And now that we have the same base, we know that our exponents will be the same. So x equals negative 3. There's no solving to do since x is by itself. So that one is done. All right, so here it is, my favorite band. If you don't know who this is, or at least don't know who my favorite band is, it's possible you don't know me at all. So maybe listen when I talk about some of this stuff in class. Some of you guys have helped me request this song for concerts that this band of mine has never played. But anyway, give them a listen.
2, 1, 2, 3, 4.